I'm checking here to see if you all are shy or asleep. And as I had mentioned before, I do have some questions, but I think that the panelists really recapped quite a bit the connection between legal structures of innovative water and how to find sort of new sources of water, and as well the water power and the water energy water connection. And so I'd like to open it up for questions. We have gentlemen over there, please.
Yeah, my name is Neil Hines, and first, Michael, don't forget your wife's birthday.
Thank you very much. That's
Yep.
good.
And I have a question for Jorge about the use of ASR by the 2060 numbers. Help me understand why it's so low. 0.9%, I think.
Yeah, I have the same question. I think what you're seeing there is what the regional water planning groups have recommended. So this is a composite for the entire state. So it is, no doubt, is very low, as are many of the other pieces of that pie. I think we're likely to see an increase of that. We conducted a study on ASR, trying to look at the challenges and opportunities for implementing ASR in the state. One of the more frequently mentioned challenges is the ownership of the water.
Mm-hmm.
There is a concern as to what happens with the water when it is injected in the ground, who owns it. So there, like that, there are so many, there are many practical issues that are needing to be addressed, that place a little bit of risk in developing ASR. I think as the need increases and the value of ASR is recognized, we're likely to see more of that.
Yeah, I saw that report, and I think they said fear was the thing people were afraid about investing. And I thought Texans like to share, and then I read that, and I was like, wait a second. But maybe as the need and the demand goes up,
Hi, this is probably too much for each one of you to answer, but I'm wondering what you think, as far as public education, what are the main misconceptions or areas of misunderstanding or just things that the public doesn't know yet about these issues?
Is that for all of us? Or, okay. I think we have an education gap, and that's always the easy default answer, is we seem to make people smarter. But there are a lot of things where even smart people make stupid decisions. We have all sorts of labels on junk food, for example, that tell us exactly how bad it is for us, and we eat it anyway. So I do think education and labeling information is useful, but at some point it becomes a cultural thing whether we should accept junk food or not, right? That will drive it. Or a price thing. If prices of junk food are higher, maybe we'll have less of it. So I think information education is a key piece of this. This is a complicated subject. There are fundamental things we don't know. In Austin, if you poll people, most people in Austin think our water comes from Barton Springs, and it actually comes from the rivers. So there are definitely some education programs we have to go through. Sort of coming through to the water comments that Kent was making, people don't realize they use more water in their home through the light switches and outlets than they do from the tap, which is sort of interesting. So there are some big gaps we should tackle, and education can be a big part of it. But I wouldn't bet the bank that that's enough. I think there has to be good policies, good technologies, good markets, good prices, along with the good education and good information.
I think education is one of the foundational issues that we have with regards to water development policy. And I see it from the perspective of innovative water technologies. It has been mentioned before that these are, for example, in the case of desalination, that is a proven, well-established technology. We see the capacities increasing around the world. But when we look at how we implement water infrastructure in the state, those decisions happen at the local level. And the idea of doing something different, something that is other than installing another well or tapping into a reservoir, doing something different like reuse or desalination, can not only be intimidating, but it might be suicidal in some cases. It's very risky. So the educational gap has a lot to do with providing accurate, reliable, good references on how these type of technologies or water management strategies work. and provide that information at a level that a city manager or an office holder can present that information and understand the issues. So for us, it comes down to providing the assistance to some of those utilities so they can develop those facts and help them make the decisions in a more, in a more justifiable way.
And I would just add that I think one of the big education issues is how much power plants are required, as Michael indicated, to not only transport water around, and that's going to become more and more critical, but also in the treatment process. One of the things I think people don't realize is as water shortages occur, typically water quality goes down. So that requires additional power to do the water treatment that you're going to need to maintain water quality standards. At the same time, if you enforce requirements for water conservation at existing power plants, depending on the difficulty and the cost of retrofitting those power plants in Texas here, where you have a deregulated market, you may end up losing some of that capacity because it's no longer cost competitive. And that may cause you more problems in the short run as far as, rates and availability of power right when you need it for, during drought conditions and also to clean up water. So these are some of the things that are competing, I guess, requirements that a lot of education is going to be needed so that everybody can make logical and informed decisions.
And I would just, I've stolen this quote from Dr. Kaiser a few months ago, never waste a bad drought. He said it this morning, and really it's the conservation mentality. We've had water resources availability. We had a drought last year. Folks were listening. More than half of our groundwater conservation districts spent so much time answering questions from the public, and there was a real desire to learn. And so we have to capitalize on those kind of opportunities, absolutely, even though there's not much else that gets good that comes from a drought, obviously.
Yes. I guess this is a question to the Alliance also. I guess the middle word in GCD is conservation. And one tactic or tool that there is for conservation is to value the product at a market price, but yet there's limits on the cost, or on the price that a GCD can charge for pumping of water. And then I guess secondly, these low rates that you can assess also limit your capability to do the job of groundwater management. We have a lot of districts that are not very viable to carry out what their jobs are. So the question is, what is your prognosis, I guess, that there could be legislative action to basically lift an artificial government rate to something that might be a little bit more market-based on the value of the water?
So you're saying what the fees that the districts charge, or?
Pumping fees, yes.
The pumping fees. Well, yeah, so I'm not sure how to answer your question. I mean, some districts are tax-based, as you know, and some districts are fee-based. And so we do have some differences in the way that districts operate. And I know that a lot of people have asked how, what is the consistency among the groundwater districts in the state? And I think that the reason for that is because, TAG has 82 members, and if I ask them a question, I'll get 82 different answers. That they operate based on their local conditions, based on the science and the uses that are availability. So I'm not sure that totally answers your question, but I think it's a good one, and we'll have to, find an answer to that.
I don't know if I can just offer just a general comment, though. Higher prices will trigger all sorts of conservation. There's no question. And then the challenge with water that is different than, say, energy or other resources is that we can't just use high prices alone to achieve all the answers, because you can price people out of the market. So there's a human rights level of water where water needs to be available for cheap or free, above which you can use prices to drive conservation. If you use prices only, then you might get conservation from people who will then die. So we have a limit there with how much we can go with it. But prices are obviously a very powerful tool. Although people dying would actually save a lot of water. So that's something to keep in mind.
And I would add that, applying a market price to what the groundwater is actually worth, and having the groundwater district charge that price might confuse things because, as I said before, the groundwater district doesn't own the groundwater, and so those administrative fees and those fees that they're doing, they're not selling that groundwater. As we all know, Day and Senate Bill 332, those those landowners own the groundwater beneath their property, so we want to make sure to keep those two, distinctly apart.
I'd like to ask each one of you that would care to comment on either the need for or potential for public-private partnerships in terms of assuming some of either the technical risks or political risks that may be inherent in some innovative systems.
We have historically put together a lot of public-private partnerships to do research to address conservation in power plants, and part of that has developed into new technologies that can be used in future plants and current plants. Another thing I would say on the public-private partnerships is that we have worked with some of our members already to develop shortage sharing agreements. So if you have a situation like you do here in Texas where ownership rights are just, stacked on top of each other and you end up with shortages, it would often take you decades or centuries to get that litigated in court and figure that out. In many cases, it's easier, and we've seen this in New Mexico and other states, to bring all the stakeholders together and develop a shortage sharing agreement. And the utility industry has typically worked in public-private partnerships like that to implement a solution for sustainability.
I'm just going to monopolize the microphone because I think Michael might kill some more people if he gets a chance to talk. So I think, yeah. So Stacy, I'm gonna take about 5 minutes to answer this 30-second question, and then it's up to you. Okay. I think public-private partnerships are a great opportunity for us here in Texas. I think it's pretty much a given in the area of technology, where you see some of these outfits that have the ability to implement a project more efficiently, just because they haven't done it many times and they know the routine. It kind of has one of the same issues in common with the other challenges that are referred to. It's new, so it's kind of hard at first to get it established, but I think the opportunity is there. I think we have seen some changes in the law that is opening this for the water industry specifically, and we're going to be seeing more of that. At my agency, we are preparing guidelines and adopting procedures for participating in those kinds of approaches to developing infrastructure. So I think this is a great opportunity for us.
And I think as it relates to groundwater, I mean, I think it's a no-brainer. As the speaker said this morning, groundwater and surface water are treated differently in this state, and groundwater is privately owned. So of course we want private landowners at the table to talk about the best opportunities in moving forward. So yeah, I mean, I think it's a no-brainer.
And I think that
I just wanted to say,
yeah.
Sorry.
I'm trying to figure out how to say this politely. I think Austin in particular has a great history of public-private partnerships with a consortia like Sematech and MCC, where we have pulled together different layers of government, academia, and industry to achieve breakthroughs. And those are usually oriented around key, discrete technological advances, where companies and governments work together at a pre-competitive intellectual property stage. So public-private consortia or agreements work particularly well for pre-competitive IP, where the technical challenges are shared across the industry. So when I look at water, I think the problem of desalination, the technical problems of that, would be a great avenue for it. When you get to larger scale infrastructure investments, sometimes the public-private partnerships break down and have a different effect. So when you start to spend billions of dollars on plants or pipes or things like that, oftentimes, unfortunately, the public-private partnership, it can go very well, but if it goes badly, what it means is you privatize the profits and publicize the losses. So I tend to feel more comfortable about it at the pre-IP technological level, where there's a better track record of success, at least in other industries. And at the large-scale infrastructure level, it's kind of harder to make it all work out the right way, I think. That doesn't mean it shouldn't be done, but you have to be real thoughtful about how you design it.
Yes, I've got another question on subsurface storage, maybe not as hard as the other one, I hope. But there's been a lot of talk about, the cost of some of this, of building reservoirs and dredging reservoirs that were brought up. But what I haven't heard, and I'd like to hear y'all, including you, Michael, is, for this subsurface potential storage reservoirs, have we mapped just how much capacity there is in the state of Texas? Is it going to be just a small amount? Is there a huge opportunity? And then what the cost will be to manage those, to get them in the right place, to lift them and distribute them again. And then it gets back into groundwater districts again, where if that reservoir is in your district, how to deal with it. But is this a great opportunity or only a marginal opportunity? And what would the cost be? Would they be cost prohibitive?
I'll take that. Unfortunately, the answer is no. We have the Water Development Board and a number of organizations, entities around the state have done independent studies on ASR potential. But a statewide study, just like you described, has not been conducted to assess the potential and the cost and all that. We haven't completed that.
And, you know, along the question of once these aquifer storage and recovery projects get going and they're within groundwater conservation districts, how do you then pull the water back out? You know, Chapter 11 of the Water Code contemplates that. I know that it has not happened yet, but I think as we get the first few under our belt and whoever's doing that project goes to the groundwater district in front and creates a permit or creates a contractual agreement and gets some certainty through that, hopefully that would alleviate some of those fears that we were talking about earlier. And in responding to was it you that asked the question this morning about who owns that water once it goes back in? And, you know, I don't know the answers to that. I remember there was a case in the 90s on the Kerrville deal. I looked it up. The Court of Appeals said some dicta about that, but it was related to whether that water permit should be, whether it was a beneficial use, if they were putting it back in. And they basically said, yeah, you're right, they may not be able to control it. So I think we will have to watch that. But by having a groundwater conservation district and getting that permit up front, you have more certainty than you would if you weren't not in a groundwater conservation district, for sure.
Michael, that might be the type of public-private partnership you were just talking about
Yeah.
to do a project like that.
And one other comment I'll make, I just keep in mind I'm a dumb mechanical engineer, so I know stuff above ground. I don't know subsurface geology. But in the power plant world, in Texas where we have all these surface-based reservoirs, the water gets hot and evaporates. And being able to store the water underground will help avoid some evaporative losses. And let's hope you don't have other losses from water traveling around. But also keeps the water cooler, which is better for power plant efficiency. So my research group's starting to take a baby step to examine what that might mean. It might be good for the power sector where they own the land and have the sites and that kind of thing. So there could be some real advantages to it.
I'm Brad Wolliver from the Bureau of Economic Geology. And I was curious, from a legal and economic standpoint, I was wondering what you all thought about the recent Texas Supreme Court case and how that might affect the development and management of new groundwater projects.
I was waiting for this question. I was surprised it hadn't come up yet. I guess I'll start unless any of you all would like to take that. So yes, as most of you know, the Supreme Court decided the awaited case of Edwards Aquifer Authority v. Dan McDaniel, and that was a case where two landowners had gone to the EAA and asked for some certain water permits, and they were denied certain amounts, and it finally came out of the Supreme Court. And there are three things that I think we can take from day. And the first is cliched, but it creates more questions than answers. If I knew what was going to happen from this point forward, I would be a wealthy person again. But we know that now there's a constitutionally protected ownership interest in groundwater in place, which really we knew before because of Senate Bill 332 from the legislature. Most districts were already operating under that assumption, and after 332, you know, almost all of them were. So it didn't really change their perspective. I think the other thing that came out of that case that we know is that the EAA acted in accordance with what their state mandated regulatory scheme said. So we don't know if a taking has occurred. It's going to be another 5-10 years before we know that. And even beyond that, Chapter 36 districts are a little different, and they have more tools in the toolbox to manage groundwater, and the court distinguished that. So that's a long answer to your question, which I think is, it seems that probably for most groundwater districts that regulate in accordance with 36, that are, you know, taking a prudent approach to groundwater management, I don't think that there will be a large impact.
I'm from California, don't look at me.
We'll let the lawyer answer. That was good.
James LeBeau, I got a question. I'm not sure who wants to take a crack at this, but it has to do with the public's willingness to pay more for water. And I think it's going to be important to anything that comes out of this meeting or anything else that's going on, is that I think the cheap water has probably all been claimed. And if we look, there was a hearing in the legislature a couple of weeks ago, in which some of the members were horrified at the idea of $4 per 1,000 gallons of desalinated water. And you just do the simple math, that's less than a half a penny per gallon, and I defy you to come up with any other finished product that can be sold for a 0.4 of 1 cent per gallon, and that's considered to be expensive. And if you look at what's, the last time that the state raised any, well, in this general revenue sense, the tax bill was 1991. And if you look at that, you might conclude that the public's ability or willingness to pay for more taxes for government is zero. What do y'all believe, or what do we know about the public's willingness or ability to pay more for water?
So I'm in the middle of a rate case on electricity that has a lot of analogs, so I'll take a first stab at this. So I'm an electric utility commissioner here in Austin, so I'm one of the commissioners for Austin Energy. Austin Energy has been going through a rate case for about 1.5 years or 2 years. It's in the paper about 3 times a day, so I don't know if you have sort of seen that. And I'm one of the bad guys, because I'm one of the guys who thinks that rates should go up because they haven't been raised in 18 years. Having not raised rates for 18 years, and now rates might go up anywhere between 8 and 13%, there's a lot of outcry for electricity. So I think raising rates is difficult in general. So that's the first comment. I think it's hard to raise rates unless people feel the sense of crisis. And I think in the electricity world, the sense of crisis is not felt. So a rate increase of 8 to 13% feels unjustified and very expensive. With water, where you can have drought and visible elements of crisis, people might have a different attitude. But I think generally it's hard. That's the first comment. People get very hung up about rates going up. The second piece is, in the end, people actually don't know what their rates are. That's the funny thing to me. And I deal with this a lot. I've been on the commission now for 4 years. People have no idea what their rates are, but they do know what their bill is. And the bottom line bill actually is more important in the end, because they really know how much money they spend on water per month, but they don't know what it is per gallon. And they know how much they spend per month on electricity, but they don't know how much per kilowatt hour. So if you raise rates but couple it with really well embedded efficiency and keep the bill the same, actually people will be fine. So that's been the approach in the electricity world, at least in Austin, to sort of get more efficient appliances out there so that your bill stays the same over time. That helps mitigate some of the outcry and outrage and that kind of thing. That's harder to do with water, it takes a little longer, that kind of thing. So I think generally it's hard to raise rates, but in the end, people actually, despite their complaints, don't know their rates, they know their bill. So it's best to work at rates and consumption at the same time to mitigate the effects.
We have time for 2 more questions, and we'll.
Okay, I just wanted to say, somebody has said before that the cheapest water that we're ever going to have is the water that we have today. And I think that is part of the problem, that we are used to very cheap water. The Water Reuse Foundation recently completed a study by Rocher, as a matter of fact, that looked at the willingness to pay to ensure a more reliable water supply portfolio under different scenarios. And that documented that people are willing to pay more. It was conducted across different cities in the Southwest. And so there is a way to measure how much people are willing to pay to increase the reliability of the water system. So that was surprising that you can actually measure that, because that's one of the difficulties of increasing rates is, you have this idea, and I used to work in utility rate design, this idea that just increasing the rate a few cents is just going to cause strikes and all that. And that might not be the case. I think there is a greater awareness from the public that water is more valuable than what we have been assigning to it. So I think there is hope in that field.
Okay, my question regards the state water plan, and apparently we have the planning process that's completely separate from the funding process, and when you have to actually put up your own money, you make different choices. So I'm wondering, to what extent does the plan represent the $53 billion solution that's most politically palatable locally versus the cheapest possible solution versus what? And to what extent do you think our ultimate solution would differ if we had to pay for it when we were coming up with how we were going to do it?
Well, that's a big question. Let me take a quick stab at it. And there are a number of people here in this audience that participate in the regional planning process, so I'm hoping that I will be fair to the question. I think what you have is a very good tool to look at the state on not just on a statewide basis, but on a region basis. The fact that this process brings to the table people that have conflicting views on how to use the resource, and that they jointly agree on what the priorities are going to be for that region and how are those needs going to be met. That is a remarkable, a state-of-the-art pretty much planning tool. And considering how fragmented our water industry is, so many authorities, so many different ownership regimes and so forth, it's pretty remarkable. So yes, that might be divorced from who actually makes the decision to implement the project, but it gives you a very strong guideline for what is going to work, what is going to have a leg up in the permitting process. And from the funding side, although the state only funds a portion of what is the water infrastructure in the state, it gives you a condition that has to be met for the use of state funding. Your project has to be in the plan if you want to implement it. So those are tools that give you the ability to impact how the priorities are going to be set and how the projects are going to be funded, just on a portion of those.
Last question?
My name is Larry Hoffman, and I'm not entirely sure that my comment or question is appropriate, but with so much emphasis on innovation and so many people interested in water, I thought I'd throw it out. And Robert Mace reminded us of it at lunch, and he talked about dams and the problem of siltation, reducing the volume of water that's available, and the problem of siltation and the high cost of removing it. And this is just an idea. Maybe you know about it. Maybe it's the dumbest thing since you know what. But trying to remove silt after a dam is constructed certainly is a tough proposal. Why can't we, when a dam is built, create on the upstream side of the dam a collection system of some sort connected through pipes and valves and periodically flush that silt out, because that silt is something that would normally flow if there wasn't a dam there. And some engineering company may have studied this already, or maybe you folks have seen or heard something about it, but to me it seems like it's worth at least thinking about. I don't know if you could even retrofit an existing dam. I think that would be much tougher, but dams have the potential to store water, and we could maybe even eliminate the in-stream flow problems below the dam. So I just throw that out as something to think about. Maybe it's a good idea, I don't know.
I can talk to that to some extent. The utility industry operates a lot of hydro dams, and
Yes.
they have an embedded interest in trying to keep those dams from sedimenting for water storage reasons too. Typically, that's not been done in the past because of the cost. If you look at trying to remove sediments that way, you're going to end up having issues with your turbines because you're passing not only sediments but say gravels too, and that has an impact on your turbines. But also there's a cost associated with putting that piping infrastructure in behind the dam. Makes it very difficult to retrofit. But we do realize now too, with the current knowledge of how reservoirs change river systems, that in some cases you do want to try and pass sediments and gravels downstream
Yes.
for, say, habitat for spawning and that sort of thing. So
Even nutrients, I believe.
we are trying to figure that problem out. It is a very expensive problem to resolve, though, for all those different reasons. Another thing is dissolved oxygen. If you're pulling water off the bottom of that reservoir, your dissolved oxygen concentrations are lower, and you can have detrimental issues with dissolved oxygen and temperature of the water going through that dam. You can have problems with fish kills downstream because your dissolved oxygen levels are too low. So all those factors have to be balanced, and we are looking at ways of trying to pass sediments and gravel downstream without having to pull them off the bottom of a reservoir. So. But it's a difficult, it's another area of research, a whole another area of research that we're trying to address.
Thank you.
Sure.
Great.
If you
Well,
got
I-
any good
I want-
ideas, let us know.
Yeah. I want to thank the panel, if we can give the panel a hand.